Okay, this video is what would be the last material on our first night of class if we were meeting together. All right, we're going to talk about multiplying and dividing these real numbers, okay? It's a little easier than adding and subtracting as far as the rules go. There's no battle of the signs to worry about or anything like that, okay? As a matter of fact, I don't usually do this, but why not? If I stick my book under here, this is just some textbook that I have used. It goes over the rules here. Come on. All right, if we look at the bottom, the product, that means multiply, of two real numbers with different signs is found by multiplying their absolute values, and the product is negative. The product of two real numbers with the same sign is found by multiplying their absolute values, and the product is positive. The product of 0 and any real number is 0, okay? All right, what do we say? It sounds like a big procedure still, but it's not, okay? The rules are easier. If we multiply two numbers that have the same sign, the answer is always positive. If we multiply two numbers that have a different sign, the answer is always negative. So 6 times negative 3, one's positive, one's negative, it's always negative 18. Doesn't matter which one's negative, okay? There's no battle of the signs here, okay? If one's positive and one's negative and I multiply them together, the answer's negative, okay? Works for fractions. Negative, what's that going to be? 2 over 15, right? All right, one positive, one negative, the answer is always negative. If they're both negative, now the answer is always positive. Two negatives multiply together to make a positive, okay? Negative, whatever, 21 times negative 2 is going to give me a positive 42. Okay? And any number, positive or negative, times 0 is going to give me a big old 0. Okay? So the rules are a little more straightforward. One positive and one negative, if you multiply it, always negative. There's no battle of the signs to worry about. If they're both negative, it's going to always be positive. Of course, if they're both positive, it'll always be positive. So if we have more than two numbers, then the procedure just kind of continues as far as the signs are concerned. You know, if I look at this problem, negative times negative gives me a positive 12, and then positive times negative gives me a negative 24. See that? What about this one? Negative 2 times negative 3 times negative 4 times negative 1, so the number doesn't get so big. Negative 2 times negative 3. Negative times negative is positive 6. Positive 6 times, let me write the whole thing. Positive 6 times negative 4 is negative 24. And negative 24 times negative 1 is positive 24. Okay, you may see a pattern. I haven't really done enough to really establish the pattern, but the pattern is if I have an odd number of negatives involved, here I've got 3 negatives, the answer is negative. If I have an even number of negatives involved, the answer is going to be positive. Okay, and if we ignore the numbers for a minute and just think about that. Negative, I'm just going to put a bunch of negatives here. Okay, well, these two are going to make a positive, right? If we just think about it. These two are going to make a positive. These two are going to make a positive. So these all kind of wipe each other out, if you will, and turn into a positive. There's going to be one lone negative left over. So this entire problem is going to be negative, whatever it is. Okay, because those two will make a positive. And then when I multiply again, I'm going to get a negative, positive, negative, positive, negative. Okay, I bet you it's an odd number, right? 1, 2, 3, 4, 5, 6. There's 7 of them. It's going to be a negative. Okay, if I stuck an 8th one on there, that makes it even. It'll turn it into a positive. Okay, so if there's an odd number of negative signs all being multiplied together, the answer is going to be negative. If there's an even number of negative signs, it's going to be positive. Okay, All cool with that little idea? -3 times -1 times 2 times -2. Immediately, I know the answer is negative because I got 3 negatives there. So I just got to take 3 times 1 times 2 times 2 and get myself a 12. Okay, -1, -2, 2 again, 3, -4. Okay, again, I immediately know it's positive because I've got an even number of negatives. I just have to take 1 times 2 is 2, times 2 is 4, times 3 is 12, times 4 is going to be 48, positive 48. If you do the signs yourself, it'll save you hassle, right? Yeah, you can just plug this whole thing in, but putting that negative in is a little cumbersome. -1 times -2 times, I guess it's not that bad, times -2 again, times 3 times -4, 48. Okay. All right, not so bad, right? Division has the same rules, okay, in terms of negatives. If I'm dividing two negative numbers, -8 divided by -2, negative divided by negative is going to give me a positive, okay? -16 divided by whatever, positive 8 is going to be a -2. Okay, so the rules are the same there in terms of the signs. Okay, a division problem can be written as the old classic division. It could be written as a fraction, right? I mean, -20 over -4 is going to be positive 5. When I have a fraction and it's a negative number, you know, there's a choice on where that negative goes. Let's just say I'm going to have the fraction -2/3, right? I can put the negative up here with the 2, and I can call it -2/3. I could put the negative down with the 3, and I would still call that -2/3. Or I can put the negative in front of the fraction bar, and I can call that -2/3. All three of those are absolutely identical, okay? You say, well, they look a little different. Well, this is some division problem, right? It's a decimal, 0.66 repeating, but it's a negative number. Negative divided by positive is going to give me a negative. Positive divided by negative is going to give me a negative, right? And this one, the negative is just kind of like hanging out front. It stays out front. Negative. Okay, so there's any of these are acceptable. None of them are wrong, but a negative in the denominator is a little bit frowned upon, so I would shy away from that. You know, so I'll just cross it out. Not wrong, but I would shy away from it. And I personally shy away from this one, the negative in front of the fraction bar, because if you get a little sloppy, I just lost my negative, and it looks like part of the fraction bar. Okay, so I personally avoid that. Now the books, all your books, 9 times out of 10, they're going to put it in front of the fraction bar, in front of the fraction bar, in front of the fraction bar, right? Because they're not going to make a typo and blend it in there the way I might with when I'm writing by hand, okay? So be aware they're all the same, but I'll almost always put it up there in the numerator, okay? But you can't put it in multiple places, because if I put it like this, now it's a positive number. Negative divided by negative, this is really now positive 2/3. So it's not -2/3 anymore. I suppose if we put it in all 3 places, okay? I mean, this is really crazy, but that's a negative number, right? Because these 2 negatives will divide into a positive, and I got a negative out front. But boy, is that overcomplicated. All right, but the rules for division are the same, okay? So if I'm dividing 2 things, whether it be whole numbers or fractions or whatever, you know, the book puts a good old negative in front of the fraction bar there. I'll do it that one time. I showed you. I'm looking at a book here for some examples. A couple of fractions there, right? They're both negative. I just happen to write one negative in front of the fraction bar, the other one not. We can stick it in the old calculator, or remember, you make it a times, and then we flip it over. Now, instead of putting the negative down with the 5, I'll just leave the negative up here, and I'll put it with the 9 instead. Same thing, right? Negative times negative is going to give me a positive, so I'll have a 27 over 20, which I could turn into a mixed number or whatever I want to do it. But it's positive. Okay. Negative 20.8 divided by 7. Not a nice, pretty looking fraction, but a division problem. You know, I can just do 20.8 divided by 7 as far as the calculator goes because I know the answer is going to be negative. And I'm going to get I'll have to round it off somewhere to 2.97 or whatever, round it off somewhere. Okay. Of course, 0 divided by, excuse me, some number, whether it's positive or negative, is a good old 0. You know, the other way around, though, is not allowed. If I didn't say that in the fraction video, shame on me, but this way would be no good. This would be undefined. You can never divide by 0. Okay, what happens if we try? Well, let's try it the first way first. 0 divided by 7, call it negative 7. We're just going to get good old 0. But try it the other way around, and you're in for a world of trouble. Divided by 0, error. No good. Can't do it. Undefined. Okay? You can never divide by 0. It doesn't matter. The negative's irrelevant. You cannot divide by 0. Okay? All right, so let's oops, pardon me. Let's mix a few things into the mix here, a little bit of more algebra, and then we'll be knocked out with this section here. One of the things that a lot of students get tripped up by, and it should be totally easy, but when I have just a negative in front of a parentheses, and let's say I had like an x plus 4 in there, that's really a distributive process. That really means -1 times x plus 4. Okay? What do? You distribute your negative across. So that's going to be negative x. And I'll just write it like this, plus -4. I'll even put the 1 in there. -1x plus -4. Okay, now that's a little clunky if you ask me. Okay, I would just say -x minus 4. See that? It's the same thing. Adding a negative is the same as subtracting a positive. And to me, this is the cleanest, simplest way to show that. Okay? I had a negative in front of a parentheses and I had x plus 4 in there. That negative just changes the sign of everything in there. Everything in there is positive. Now everything in there is negative, except I choose to write it like that for kind of like shorthand. Otherwise, I would have to write it like this. Keep that plus sign, but then the 4 becomes a -4. Okay, same value, same thing. This is cleaner though, if you ask me. So I'll always write it like this. Okay, but that's certainly not wrong. It's just not as simple as I would like to see it. So let's just practice a couple of those. What if I had some negative out front here? If they were both positive, we'll say 11x plus 5. Again, I'm just going to distribute that negative and get -11x, and I'll just call that -5. Okay? What if there's a negative out front? What if it was 11x? What if it's already -5? Well, I'm going to distribute that negative. Now I get a -11x, but now it's going to be negative times negative is going to give me +5. Okay? What if the 11x happened to be negative? Well, you know what's going to happen. Negative times negative is positive 11x. Negative times positive is -5. Okay? And of course, if they were both negative inside, I'm going to distribute, and now they're both going to be positive. 11x plus 5. Okay? All right, so let's work a couple more like that. Easy peasy. -2 times 3x, negative times positive is going to give me a -6x. Okay, this is just kind of a recap of a lot of stuff here. 6x plus 1 more x, everybody's positive, 7x. We got that one down. 8a minus 9a. Well, I choose not to call it 8a plus negative 9a, but you're free to. Okay, I just think it's unnecessary. That's a positive 8 and a negative 9 in my mind. When I put them together, I get a negative 1a, which we could, of course, just call negative a if we wanted to. Okay, how about negative 3 parentheses 2x minus 5? Negative 3 times 2x is negative 6x. Negative 3 times negative 5 is positive 15. Negative in front of a parenthesis should be easy, sometimes causes trepidation. Negative 3y plus 8. Distribute that negative across. All right, let's try one more bad boy here, and then all of a sudden, we will be done with our first night of class. How about that? Went by pretty quick, didn't it? Okay, how about this one? We're distributing a good old positive 5. That's going to give me a 10y minus 9 times 5 is 45. Here I'm distributing a negative across that second parentheses, so that becomes negative 9y plus 8. Okay? Easiest way to write it. Negative 9y plus 8. Even though I just said negative 9y, even though it doesn't read that way. It reads minus positive 9y, but in my mind, that's plus negative 9y. I just call it negative 9y. That's the interchangeability of those words, minus and negative. They're not really the same, but you can sure make an argument that they are, because you can just turn one into adding the opposite. All right, let's combine now. Now, you can only do the old shuffle game if it's an addition problem, right? Let me write it down here. You can only do the old commutative property, the old shuffle game, if it's an addition problem. It's not an addition problem, right? Yeah, it is, mentally. If we rewrite it, as I'm doing it down here just to show you the way I prefer not to do it, because it's extra work. And I'm not a fan of skipping steps, but I'm a fan of eliminating what I call unnecessary steps. Now, maybe they're necessary for you, and that's fine. But once you get the hang of it, I don't think they will be. So I'm going to change that minus to plus, and that 45 to negative 45. I'm going to change that minus to plus, and that 9y to negative 9y. Now I truly have an addition problem. Commutative property, I can do whatever I want. I can shuffle stuff around. I can move it around either physically or mentally, but I can now see these y's are now added together. A 10y plus a negative 9y is going to give me a positive 1y. And a negative 45 plus an 8 is going to give me a negative 37. So I could write plus negative 37. Okay? You can do it here. Look at this. 10y minus 9y, just subtract them. 10 minus 9 gives me 1y. A negative 45 and a positive 8 gives me a negative 37. I can just write it as minus 37. Okay, you see there's a difference in appearance between these two, but they are not different answers. There's the same answer, just shown a little differently. Okay, so work on it if that troubles you at all. I don't think it should. All right, that's again, what we would have done on our first night of class. So that's going to be it for me for tonight also. So some other night I'll pick up on recording some more videos, but hopefully things are going well so far, and I'll see you in the next video. Thanks.